Welcome to the Exam 2 review. This is the review video in preparation for the second exam. Second exam covers everything between chapters 7 through 10, and this is everything between sampling and simple experiments. 7 is sampling, simple experiments is 10. What we're going to do is we're going to go through a previous exam that I have given and make sure that we understand what is happening with the scenarios in this particular exam. Now, this is a lot of scenarios in this one, so be ready for this. All right, let's go ahead and start with the first scenario. Researchers are interested in the mother's experiences with empathy for their children. Specifically, the researchers think that mothers whose children have a negative experience will empathize more with their children than mothers whose children have a positive experience. Okay, so right away, let's go ahead and start diagramming the study. Let's go ahead and start diagramming the study right here before we even get into any of the questions. So number one, we know that my pen is doing stupid things. We know that we have two different things right here. So when you're looking for the conceptual variables, look at the hypothesis, all right? So we have the mother's experience, and the outcome is going to be empathy. All right, so let's see how those are operationalized. The researchers personally knew several mothers and asked those mothers to invite other mothers to participate in the study. 60 mothers volunteered for the study. 30 of these mothers had children over 18, and 30 had children younger than 18. The researchers asked the mothers of the adult children to imagine their children getting an A+ on the college exam. The researchers asked the mothers of the children under 18 to imagine their children being bullied at school. The researchers then measured empathy by measuring mothers' heart rate in beats per minute. So let's go do that last part. Empathy is being measured by heart rate. Okay, and that's an arrow going down. All right. Now, what about this one over here? What about this other variable? Well, this other variable, the operationalization of that is that the researchers put them into two different groups and asked them to do two different things. One is the A+ group, right? So that's positive. The positive experience would be the A+ group. And the other group is the negative experience, and that's bullying. And since the researchers are doing that, the arrow goes up. I don't know if you can see that very well, but the arrow is going up from square to circle. This is an experiment. They're saying that the experience causes the change in empathy. All right, let's go ahead and start doing some of the questions, and we'll get to some of the positives and negatives of this particular design. What kind of sampling was done in this study? This was snowball sampling, and snowball sampling is a kind of biased sampling. Snowball means you get one person who knows somebody, and they get another, and they get another, and they get another. So in this case, you find one mother, and they find another, and they find another, and they find another. Question 2. What of the following was used as a sampling frame for this study? There was no sampling frame used for this study. Biased sampling doesn't use a sampling frame. A sampling frame is a list of all the people in the population. We do not have a list of all the mothers of children. We don't have that, and we certainly didn't get our sample from that. So we don't have that. What kind of data will the researchers collect from this study? Well, they're collecting heart rate, remember? And so 0 beats means 0. 0 beats is 0. That means we'll probably have ratio data. And ratio data is a form of continuous data. Number 4, this study operationalizes how many variables? This study operationalizes 2 variables, one independent variable and one dependent variable. So the one independent variable has 2 levels. The independent variable, remember, is the children's experience. And the way that they are operationalizing that is either thinking about A+ or thinking about bullying. Those are the two levels of the independent variable. So this is one independent variable with two levels and one dependent variable. Question 6. Which of the following was part of the study? Well, in this case, none of these were part of the study. There was no random sampling because we didn't use a sampling frame. It wasn't random. There was no random assignment either, because the way it was assigned was that the mothers who had children 18 and up were put into the positive experience condition, and the mothers with children under 18 were put in the negative condition. That's not random assignment. This is not moderation, because moderation means you have to have two independent variables. We only have one independent variable in this study. So none of these were part of that study. Which of the following is true of this experiment? This was an independent groups experiment. Independent groups because we have two separate groups. Mothers with children over 18, mothers with children under 18. Those are the two groups. Okay, they're independent groups. Then that means that they weren't within. Within means the same mother has to do a positive experience and a negative experience, right? There was not a pretest post-test, because a pretest would mean we'd have to measure their empathy beforehand and then measure it again later on. We didn't do that. Okay, question 8. Before the study started, some participants had higher blood pressure than others. This would be an example of, this is unsystematic variability. Unsystematic. Systematic means there's something that we do in the study that's systematic. And we'll get to that in just one second, because we're going to do this as an example of the essay question. But unsystematic means just, random stuff is going on behind the scenes, and that might have an effect. So how high your blood pressure is before you even come in, right? That's going to be unsystematic. Could it have an effect on your empathy? Yeah, theoretically it could. But it's not part of the study. It's not something that's happening because of part of the study. Let's go ahead and look at systematic and confound by looking at some of the essay questions for this. The first essay question was the diagram of the study. Notice this is an experiment because we manipulated the variable, and this experience causes empathy, and then empathy is measured using the heart rate. So you either set an A+ or bullying. That is the operationalization, which is the manipulation of the independent variable experience. That changes empathy, and that goes down. Now, whether it's a good manipulation is a totally different question. Because B, describe a problem with systematic variability in this study. Now, the biggest problem should be really obvious to you, and that is that the people in the A+ group, those were only mothers who had adult children, and the people in the bullying group were mothers who had younger children. So this group, this is not a random assignment, which means we don't know if it was actually experiences causing the change in empathy, or it could be a different variable, one that we would call a confound. So that is like age of child. Whoops, I don't know how I'm moving that around. Age of kid. Well, how did I even do that? It's amazing. I didn't know I could even do that. Age. Come on. Anyway, age is a confound. Let's put it over here. Age is a confound, and it could be the one changing empathy, right? That would be systematic because the way we put people into groups is part of the study, and therefore that could be what's really causing the change. Okay. Look at the following output from RStudio. Would the statistical test represented in this output be used to test the hypothesis of the study? Let's look at this. This is a Pearson's product moment correlation. That's a Pearson's R. There's the correlation right there. Okay? Because we have a categorical variable with two levels as the independent variable, and outcome, the dependent variable, is a continuous variable, correlation is not appropriate for this. Pearson's product moment correlation, that is a lowercase r, is not appropriate for this. A t-test is appropriate. But wait a minute, you say, look, there's a t right there. No, that's not a t-test t. That's this correlation coefficient being transformed into a t so we could figure out what the p-value is right there. This is not appropriate because we should be using independent groups, independent samples t-test for this. All right, next scenario. Researchers wanted to test whether exercise improves test taking. The population for this study was all elementary school students in Denver. The researchers had a list of all of the elementary schools in Denver. They randomly chose 10 elementary schools. Each of these schools looked at their list of students and randomly chose a number. Then they took every 100th student until they had 30 students chosen. The 30 students from each of the 10 schools were chosen for a total of 300 participants in the study. Okay? All 300 participants were given 5 extra minutes of recess every day for 1 week. Then after that week was over, all the students completed the following Sudoku puzzle. The researchers measured test-taking ability by timing how long it took the students to complete the Sudoku. Then the participants were given 10 extra minutes of recess for 1 week. Then they completed another Sudoku puzzle. Then the participants were given 20 extra minutes of recess for another week. Then they completed another Sudoku puzzle. Researchers found that participants who had 10 extra minutes of recess were significantly faster completing the Sudoku than when they had only 5 extra minutes. They also found that participants were significantly faster after the week with 20 extra minutes compared to the week with 10 extra minutes. They concluded that exercise improves test taking. Good for them. Let's go ahead and diagram this study for you. So here's the hypothesis. We want to know whether exercise improves test taking. So I'm going to do this over on the side. So this is, I don't know what's going on with my pen today. So let's do it over here instead. Exercise and test-taking ability. All right. Now we know that they measured the test ability by the amount of time for the Sudoku. Right? And what about this idea of exercise? How did they get at that? Well, what they did is they gave the kids extra recess time. So the researchers changed the amount of exercise that was happening in the kids. They either got 5, 10, or 20 extra minutes. But wait a minute, you say, those aren't in different groups. You're right, it's the same students who got 5, 10, or 20. It's still a manipulation because the researchers changed it. That's what this should look like. What kind of sampling was done in this study? So number 9, what kind of sampling? This was multi-stage sampling. Each of the different schools was a cluster, and then within that cluster, they used systematic random sampling. So that is a multi-stage sampling. And it is not biased, it's representative. Okay, that is not a biased form of study, it is representative. Which of the following is true? Well, this was an experiment. We know it wasn't a correlational design because they manipulated the amount of exercise going on. They didn't measure the amount of exercise going on. Then they measured the test-taking ability. This, we don't know whether or not they made a type 2 error. Is there a possibility they did? Well, that depends on what their conclusion would be. All right, let's find the conclusion. They concluded that exercise does improve test-taking ability. So that means that they rejected the null hypothesis. That means that they could not have made a type 2 error. They could have made a type 1 error, and they could have been correct in their conclusion. This was not a mediated design because mediated designs require at least 3 variables. There's only 2 variables here. 11. What kind of data will the researchers collect from their dependent variable? The dependent variable here is the amount of time it took for them to finish the Sudoku puzzle. That time, so 0 minutes means 0, and so this is ratio data, which is the same as continuous data. This study operationalizes one independent variable, and that independent variable is the amount of exercise. There's 3 levels to that variable: 5 minutes, 10 minutes, 20 minutes. Then there's one dependent variable, which is the amount of time it took you to complete the Sudoku puzzle. Okay? Which of the following statistics would be used to test this hypothesis? None of these would be used. None of these would be used to test this hypothesis. Because what we do when we manipulate a variable is we put people into independent groups. We always treat that manipulation, those 2 independent groups, as categorical data. It's always going to be categorical data. Even though 10 minutes is more than 5 minutes, that, in this case, it doesn't matter. We're still going to use it as categories. Okay? We're still going to use it as categories. So none of these would be used. We would actually use what's called a one-way analysis of variance for this. But we wouldn't use a Pearson's R because it's not a continuous compared to continuous. We wouldn't use a capital R because that's more than one variable on an outcome variable. We wouldn't use a T because we have more than 2 levels of the independent variable. We have 5 minutes, 10 minutes, 20 minutes. Those are 3 levels, and t-test can only do 2 levels. 14. Which of the following is a problem with this study? All right, well, let's take a look at it. Number 1, did they have order effects? So order effects means the order that these things happen is going to be a problem. Examples of order effects include the practice effects or the carryover effects. So for example, we always know that they did the 5 minutes. They gave all the kids 5 minutes extra for a week first, and then the next week was 10 minutes, and the next week was 20 minutes. The order was always the same, so we definitely could have order effects. So for example, an example of the order effect would include the fact that they were more practiced at doing Sudoku puzzles after the first week. So they did better in the second week, and they were more practiced after the second week. So by the third week, they might have practiced a lot. And it could be the practice, which is a form of order effect, that is causing the change in the time instead of just the exercise. So let's take a look at the other ones. Their sampling was not representative. Was their sampling representative? It was, because cluster sample, well, in this case, multi-stage, right? It started with cluster, and then they did systematic random within the cluster. That is representative. Is there covariance in this study? Yeah, you can covary, right? As more exercise increases, so does the more exercise increases, lower time to complete the test. Yeah, that's covariance, absolutely. 15. Which of the following is true of the study? All right, let's take a look. This was a within groups experiment. Yes, that was definitely a within groups experiment, because the same students were given 5 minutes, and then they were tested. Then they were given 10 minutes, and then they were tested. Then they were given 20 minutes, and then they were tested. That is a within groups design, because each of the participants experienced all 3 levels of the manipulation. This was not an independent groups design. This was not a pre-test post-test design. A pre-test post-test would mean you'd be tested before you did anything. Then you're in your groups. You get manipulated, and then you take the test again. In this case, they did the manipulation, one level of the manipulation, which is 5 minutes of extra exercise. Then they were measured, etc. So this was a repeated measures design. It was not a pre-test post-test design. This was not a post-test only design because it was repeated measures in a within group study. All right, let's go through some of the essay questions for this one. So first, the first essay question for this one was diagram the study, which we did before, right? That's this right up here, okay? But it also says include a confound in your diagram. So a good example of a confound would be a form of systematic variability. So in this case, something else that could be causing the change in testability. So for example, a practice effect, right? It could be that the way that we did the study led them to practice more because, you know, by the time they're in the 20-minute exercise group, they've had 2 weeks of practicing Sudoku puzzles. So their practice because of the order was always the same, 5 minutes, 10 minutes, then 20, would have been practice effects. What they should have done is randomize the order, or at least counterbalance the order of these of the manipulations. What would need to change in order to run a multiple regression on this study? And why would that need to change? So for a multiple regression on this study, you would need to have another predictor or independent variable. That would be the first thing. And the way we've talked about these, we've always measured them, though technically it doesn't have to be a measurement. We've always done it with continuous data as well, though technically you don't have to do that. So one way you could do this is just measure how much time the kids are spending exercising at recess. You'd still measure how long it took them to do the Sudoku puzzle, but you need another variable, right? Another predictor variable, something else that's going to change the amount of time it takes them to do the Sudoku puzzles. For example, maybe an IQ score, or perhaps happiness, or friendliness, or any or all of those, right? A multiple regression needs more than one predictor variable on an outcome variable. More than one predictor on the outcome. The outcome would be how long it takes you to do the test. The predictors could be whatever they want, whatever you want them to be. The way we talked about it in class, though, they'd be continuous measurements. Next scenario. Researchers have a hypothesis that loud noises causes hearing loss, and that hearing loss causes people to have poor social skills. To test this, researchers randomly select 100 CU Boulder students from the student roles using a random number generator. Observers follow each student for 1 day. During that day, the observers measure how many minutes, during the day, how many minutes in the day the participant spends with headphones on. Then they observe every social interaction and rate the participant on their social skills on a response scale from 0 to 10. The next day, each participant is given a hearing test by a doctor, is given a score from 0 to 100 that indicates hearing loss. Okay. Diagram the hypothesis of the study. All right, so the hypothesis is just to say that hearing loss causes, loud noise causes hearing loss. Hearing loss causes people to have poor social skills. So we're not going to diagram the operationalizations yet, but we're going to take the first variable, which is noise, causes hearing loss, causes social skills. Okay, that's their hypothesis. Number 16, which of the following is true? This was a mediated hypothesis. This was also a correlational design. Even though their hypothesis said cause, they can't show causation here. They can't show the causation. They have a problem with this. They can't show the causation here. Okay? They can't show the causation. So this was a correlational design and a mediated hypothesis. That was both of those. Give an example of a problem with temporal precedence in the study. Now, in this study, temporal precedence means that the things that are causing the outcome have to come first. So the problem here is that they measured the hearing loss after they did social skills. Okay, we're going to review that later because I'm realizing I did that out of order. All right. 17. Which of the following would be used to test this hypothesis? Now, this is a mediated hypothesis. And you remember when we talked about mediation analysis, we need both a Pearson's R and the betas in order to do that. We need a Pearson R and a beta. So first we would run the Pearson's R between everything, and we would assume them to be significant. And then we want the beta between the first variable and the last variable to no longer be significant. So what that means is first you run the R's of all of these, right? Run this R, run this R, run this R, okay? All of those R's. Then you run the betas, and since noise and loss are the only predictors and social skill is the outcome, we would get a beta for this one and we'd get a beta for this one. We want this beta to be significant. We don't want that beta to be significant. That would indicate a mediated design. 18, to test the hypothesis, which of the following would I test? This is just barely what we talked about. The correlation between headphone time and hearing loss. So headphone time, that's the loud noises, right? So we would do that correlation. The correlation between hearing loss and social skills, we would do that one. The correlation between headphone time and social skills, we would do that one. We would do all of those. You do all of those correlations, and then you would still run the multiple regression. 19, which of the following is true? I would use multiple regression in this study. You would need multiple regression for that study because you got to find the beta weights. What about a t-test? You don't run a t-test because there's not any categorical variables there. We don't have any categorical variables, so we don't even know if there's two levels. Excuse me. Excuse me. So we would not run a t-test. I would use a repeated measures design in this study. This is not an experiment, so you don't use a repeated measures design. I mean, it would be nice. You should, perhaps, but they didn't in this case. You counterbalance the order of the manipulations in the study. Now, in this particular study, there were no manipulations. You probably should counterbalance if you did run this as an experiment, but they didn't in this case. 20. What would be an example of beta in this study? All right, now beta, if you remember, is the effect of one predictor variable on the outcome variable independent of any other predictors, right? So, for example, the effect of headphone use on social skills without the influence of hearing loss. That would be a beta. The effect of both headphone use and hearing loss on social skills, that's a capital R. The Pearson's correlation of headphone use on social skills, that's a lowercase r. The likelihood of making a type 1 error, well, the likelihood you're willing to accept is your alpha. The probability of doing that is a p-value. 21. When I test the effect of headphone use on social skills, which would I want to see from my results? All right, headphone use is the first one, so let's take a look at it. Let's look up here. Headphone use is noise. That's the same thing. Headphone use is noise, right? Headphone use on social skills, okay? What I want is the beta to not be significant, but the Pearson's R to be significant. So let's take a look at that. All right, this Pearson's R, is it significant? No, it's greater than 0.05, it's not significant. The capital R, am I looking for the capital R? I'm not, so I don't care about that one. This beta, do I want the beta to be significant between headphone use and social skills? I do not want it to be significant. So C, this is the correct answer. I would not run a t-test, it wouldn't matter. So this non-significant beta is the correct answer because that's what I would want. I don't want a significant beta between headphone use and social skills. I only want a significant beta between hearing loss and social skills. What is alpha in the study? Alpha is the probability the researchers are willing to accept of saying that hearing loss leads to lower social skills, when in reality it does not. It's the probability you're willing to accept of making a type 1 error. Okay, that's what it is. Okay, let's keep going. 23. Which of the following is an example of effect size? Effect is how big of an effect does the one variable have on the other, right? So the amount of variability in social skills that is due to variability in hearing loss, that is the effect size. That's the effect size. All right, last scenario. I think this is the last scenario anyway. Researchers are interested in how vegetarians are affected by neuroticism. The researchers posted advertisements for their study in 20 different vegetarian restaurants in the state of Colorado. Only vegetarians were accepted in the study. 100 vegetarians replied to the ad and were included in the study. Each of the participants replied to the following questions. I'm neurotic, I am an emotional wreck, and they gave their agreement. The researchers assigned numbers to the amount of agreement, added the two scores together to get the participants' neuroticism score. All right, so I'm not gonna diagram this yet. We're gonna get to that in just a minute. What kind of sampling was done in this study? First of all, This was biased. This was biased sampling. It was actually a purposive sample. Okay? It was a purposive sample. We were looking, we put up advertisements, and whoever replied, that's what we got. 25. What was the sampling frame for this study? There was no sampling frame for this study. A sampling frame is a list of all the people in the population. So we need a list of all the vegetarians in Colorado. We didn't have one for this. There is none. 26. What kind of data will the researchers collect from this study? Well, they're using a Likert scale. So they're going to get ordinal data, which is continuous data. 27. This study operationalizes. All right, now we can get to the, now let's get to the actual study itself. If you look at this study, researchers are interested in how vegetarians are affected by neuroticism. The researchers posted advertisements for their study in 20 different vegetarians. They only accepted vegetarians into the study. They did not manipulate or measure. They did not manipulate or measure vegetarianism. All of the participants are vegetarians. They only measured neuroticism. So the only thing that they did was measure neuroticism using their scale. That's the only thing they did here. So that is one variable that they measured. Which of the following would be used to test this study? None of those, because you only measured one variable. When you only measure one variable, you're just talking about like percentages and things. For all of these, a beta, a capital R, and a lowercase r, you need at least two variables. And for a beta and a capital R, you would need at least three because they're multivariate. So none of those would be used. 29. This scenario does well at establishing covariance? No, it doesn't establish covariance because there's not more than one variable to covary. So it doesn't do any covariance. Temporal precedence? You have to have more than one variable to do temporal precedence. One variable comes before the other. That would be temporal precedence. We can't do that here because we only have one variable. Internal validity? There's no independent variable that's being manipulated, so we can't tell whether or not it's affecting a dependent variable. 30. Which of the following would need to happen in order to run a t-test on this study? All right. They would need to add an independent variable. They need to add at least one independent variable, okay? In this case, it'd have to be just one because a t-test can only do one. And that would have to have two levels. They don't have an independent variable currently. And they would, so they can't do any of those other ones. So what they need to do, for example, is they need to at least go in there and they either manipulate vegetarianism, where they take a bunch of people and randomly assign them to be vegetarians or not. That would be a good t-test, okay? And that would be a good experiment, but that's not what they did by any means. Or they need to measure whether or not you are or are not a vegetarian, and then measure the amount of neuroticism. That would also be a t-test you would use, even though that would be a correlational design. Let's go through some of these other essay questions. Give an example of a potential problem with construct validity in the study. Does that problem with construct validity threaten internal validity in the study? Why or why not? So the only part of the study is neuroticism is being measured. That's it. So the only part of construct validity is whether or not that scale is any good. So for example, if you think that people are not likely to answer truthfully to the questions, I am neurotic and I am an emotional wreck, that would be a problem with construct validity, right? That would be a good one. But this is not threatening internal validity because you do not have a manipulation. This isn't an experiment, so that's not a threat to internal validity at this point. Last question. What's the difference between the value of the statistic and the p-value? Which is more important for determining statistical significance? So the value of statistic is, let's say we're doing like a t-test. So p equals 2.30, right? That is the statistic, and it says that there is a difference between the two levels of the independent variable, or levels of the predictor variable, whichever one you're doing. Okay, so there's a difference between the two levels, the two groups. The p-value is the probability of getting this number when the null hypothesis is true. So when the p-value is less than 0.05, that means that the probability of getting 2.30 when there is no real difference between those groups is less than 5%, right? There's less than a 5% chance of getting a 2.30 when there's really no difference between the two groups. That is the difference between the p-value and the statistic. All right, I hope this was helpful for you. Good luck. Keep studying.